Even as the first rockets were launched into space decades ago, aerospace knew it was a wasteful process. Rocket stages, motors, and complex equipment crashed into the ocean or burned up in the Earth's atmosphere. Could space planes bring the cost down? Flying to orbit with a combination of jet engines and rockets, and then safely re-entering the Earth's atmosphere again. Single-stage to orbit spacecraft and space planes have always seemed out of reach, and actually not that practical. But what about a two-stage, fully reusable spaceplane? Exodus Space Corporation has been secretly working on this concept for a decade now, and what they're planning is pretty revolutionary. Traditional rocketry is a wasteful process. Engineers and workers build one of the most complicated vehicles ever imagined by humanity. A single launch can cost more than $1 billion. A lot more. Then this beautiful, complicated machine blasts off through the atmosphere, with stage after stage detaching to reduce its weight as it burns through its propellant. These stages crash into the ocean or burn up in the Earth's atmosphere, and they're lost forever. A tiny fraction of the original rocket will ever return to the surface of the Earth, and from this point on, its home will be a museum somewhere. The solution, of course, is to build a fully reusable rocket. Have the whole vehicle fly to space, perform its mission, return to Earth, refill it again, etc. This isn't a new idea, and the aerospace industry has been chasing this goal for decades. The US Department of Defense started work on a reusable launch vehicle concept back in the mid-1950s, before Sputnik had even launched. The X-20 Dinosaur was the Air Force and NASA's attempt to build a reusable orbital glider. A rocket would carry the tiny spacecraft to orbit with a single passenger who would carry out a space mission and then re-enter the Earth's atmosphere and glide to a safe landing. They'd even chosen 6 pilots. But then the program was scrapped in favor of the Gemini program. In 1957, NASA investigated the possibility of recoverable space boosters, which would launch horizontally, pulling in oxygen from the atmosphere, compressing it, and then liquefying it for use in a scramjet engine. The agency realized that developing a single vehicle that could move through subsonic, supersonic, and hypersonic speeds was just beyond the capability of their technology at the time. So they focused on reusability, developing a vertically launched spaceplane that would reuse as much of its hardware as possible. This was, of course, the Space Shuttle. The goal for the Space Shuttle was to be a human-piloted spaceplane that could deliver cargo to space stations, launch, repair, and retrieve satellites, deliver rocket stations and propellant to space for missions to the Moon, Mars, and beyond. Their original concept in 1969 looked a bit like 2 space shuttles stacked on top of each other, with a larger flying fuel tank that would serve as a first stage, carrying a smaller orbiter. Both were fully reusable, able to launch vertically and then land horizontally. But the laws of physics and the technology at the time conspired to make this impossible. Although it was one of the most complicated and advanced vehicles ever built by humanity, the Space Shuttle failed to live up to the promise of a fully reusable spaceplane. The main fuel tank was destroyed with each launch. The twin solid rocket boosters landed in the ocean and required significant refurbishment. Even the Space Shuttle orbiter required refurbishment, bringing the launch cost to about $450 million per flight. But the dream was still alive, and NASA was working on a next-generation reusable spaceplane called the X-33 Venture Star. Equipped with the revolutionary linear aerospike engine, the X-33 was designed to take off vertically, fly to orbit as a single stage, release its cargo, and then land horizontally. Contractor Lockheed Martin got deep into the development process, building large portions of the spacecraft, but in the end, the program was canceled because of politics and struggles to build the fuel tank strong enough to handle the liquid oxygen needed by the engine. But even if it could have flown, the total mass it could carry would be extremely low compared to multi-stage rocket systems, like the Space Shuttle. Single-stage to orbit spaceplanes never took off because the orbital payload is so low it's not worth the effort. They always seemed promising because jet engines at lower altitudes can pull their oxygen in from the atmosphere, saving weight. Companies like Stratolaunch and Virgin Orbit are working on aircraft-launched rockets, and Pegasus rockets are regularly launched from aircraft, but these still discard most of the stages of the rocket. The path chosen by SpaceX is a fully reusable, multi-stage rocket, the Starship and Super Heavy booster. And thanks to their proven technology of powered landings, both the top and bottom stages of this rocket system are fully reusable. It gives all the heavy lift capacity of a staged rocket system without having to throw everything away. Is this the best possible launch system? We've talked about the United Kingdom's Skylon Spaceplane, which uses hybrid jet engines to work at lower altitudes and then transition to rocket engines at higher speeds and altitudes. The problem here is that it's still a single stage, needing to carry all that empty propellant tank into space, reducing the amount of cargo it can launch. In theory, the most efficient possible system is a multi-stage, horizontally launched spaceplane which operates like a jet at lower altitudes and then transitions to a rocket at higher altitudes. Imagine a Skylon that could break in half. And a new company called Exodus Space thinks they've got the solution. Their design is called the Astro Clipper, and in theory, it'll become the first fully reusable two-stage spaceplane. All the benefits of an airplane using aerodynamic lift and jet engines, and all the benefits of a multi-stage rocket, removing a stage when it's out of propellant. So let's talk about how it works. The Astro Clipper would launch horizontally from a spaceport runway using its air-breathing jet engines. Thanks to advances in technologies, supersonic engines can now use 20 to 50% less fuel than previous generations of jet engines. This reduces the total mass of the vehicle while still allowing it to take advantage of atmospheric oxygen as it climbs altitude. As it's climbing through the atmosphere, it has a very high lift configuration to gain altitude with the least amount of fuel. It's built like a thin airfoil to minimize drag in the atmosphere as it climbs to an altitude of 18,000 meters or 60,000 feet. At this point, it's traveling faster than Mach 1.5. Then the jet engines shut off, and then the rocket engines take over. Unlike previous spaceplanes like the Space Shuttle or X-33, Astro Clipper won't need liquid oxygen on board with the more complicated and heavy cryogenic fuel tanks. It'll use jet fuel with atmospheric oxygen at lower altitudes and then switch to jet fuel and hydrogen peroxide as an oxidizer when it's firing its rocket engines. This pushes the vehicle to an altitude of 65 to 95 kilometers, or 40 to 60 miles, where the two stages separate from each other. The booster stage fires its rocket engines to reorient itself to return to the thicker atmosphere, gliding to a landing on a spaceport runway. The upper stage continues on to space, delivering cargo, carrying passengers, or chasing down a piece of space debris. Then, when its mission is over, it can return back to Earth, re-enter the atmosphere, and glide to a landing like the Space Shuttle. Because it's fully reusable, each Astro Clipper should be capable of flying up to 10 times a year for over 20 years. Spaceplanes like this will have many advantages over traditional rockets, even reusable rockets like what SpaceX has in the works. They're far less concerned about weather, operating at times when rockets can't fly. They can launch and land at spaceport runways instead of a full rocket launch complex. They just need a long enough runway. One spaceplane could take off from a spaceport, fly under jet power to a satellite manufacturer, for example, refuel, and then carry a cargo to space. There's nothing else like this out there. And a spaceplane has an abort capability that traditional rockets don't have. In the case of an abort with a space launch system, for example, the whole rocket has to be destroyed once it gets off the ground. But with a spaceplane, if there's a problem, it can just glide back to a runway for service. At higher altitudes, the orbital stage can abort and return to the runway, carrying the expensive cargo safely back to the ground. So how could this play out in the next few decades? We'll get to that in a second, but first I'd like to thank Ziggian, Chandra Kondapaneni, Murray Hayes, Spencer Height, and the rest of our 827 patrons for their generous support. Educational content should be freely available to anyone in the world, and the patrons make this possible. Join our community at patreon.com/universetoday and get in on the action. Thanks to advances in technologies, it might finally be the time to build multi-stage reusable spaceplanes. Exodus has actually been working on this idea for a decade, raising private funds and operating secretly to work out the technology. Their first goal is a scaled-down prototype version of the Astro Clipper called the Astro Clipper Nano, launching as early as 2024. This suborbital vehicle will be capable of carrying a 100-kilogram payload to an altitude of 100 kilometers. In addition to demonstrating the technology, the Nano would be capable of delivering payloads around the planet within a couple of hours, in a market they think should be worth tens of billions of dollars in the near future. By 2026, the Astro Clipper Micro version will launch 300-kilogram payloads to low Earth orbit, launching microsatellites. This version might also be capable of assisting with space debris collection, matching the orbit of space junk inexpensively, and then bringing it back down to Earth. By 2030, Astro Clipper Mini will launch full satellites carrying up to 1,200 kilograms to low Earth orbit. It could also refuel satellites and perform various satellite servicing missions. In the early 2030s, the Astro Clipper Cargo will carry 4,800 kilograms to low Earth orbit, transporting cargo to space stations or to lunar transfer orbits. By the mid-2030s, Astro Clipper Crew will be able to carry 20 people to low Earth orbit or provide point-to-point transportation around the Earth. It's funny when you look back at the first designs of the space shuttle in the 1960s. You can see that the engineers had the fundamentally right solution. 2 stages, both of which can take off and return to a runway for refueling. But it's taken over 50 years for the manufacturing, materials, and technology to catch up with the vision. SpaceX has taken the spotlight with their emphasis on a fully reusable rocket system that should dramatically lower launch costs by several orders of magnitude. But this technology space is evolving quickly, and now, in just a decade or so, we can see fully reusable 2-stage space planes making their way to orbit, providing even more ways to get to space. What do you think? Let me know your thoughts in the comments. Here are the names of the patrons who support us at the $10 level and more. Want to see your name here and support the work we do? Go to patreon.com/universetoday. Once a week, I gather up all my space news into a single email newsletter and send it out. It's got pictures, brief highlights about the story, and links you can find out more. Go to universetoday.com/newsletter to sign up. Did you know that all of my videos are also available in a handy audio podcast format? So you can see the latest episodes as well as special bonus materials like interviews with me show up right on your audio device. Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Speaking of the SpaceX Starship, we just had a presentation from Elon Musk about the state of the Starship Mark 1 and when it should be making its first orbital tests. Here's a whole video about it. Click here.